Alors donc, nous allons aborder la dernière table ronde consacrée.
We will now begin the final roundtable, the title of which is From Below Ground to Outer Space, Regulations and Climate Challenges. You'll see there's a surprise. So our colleague and friend, Gépy Koudadje, who is a lawyer at the Paris Bar Council, she founded a think tank, Lex Natura, which focuses on the environment rights. She will be your facilitator. I'll give her the floor now. Thank you so much.
Bonjour à toutes et à tous.
Good afternoon. I'm delighted to be with you today and to serve as your moderator. We have a very broad topic, from below ground to outer space, regulations and climate challenges. To kick off, I would just like to start with a few introductory remarks on regulations in that field, on top of the environment rights. Since the Paris Agreement of 2015, we have a sustainability law that aims to supporting companies in their green transition. Since 2015, the law has changed. The PACT Act came around, and now it provides for environmental matters to be taken into account by companies. So from 2019, the Green Deal, in 2019, the Green Deal was launched, and there were a number of EU regulations that were adopted to support companies. You have a green taxonomy, for example, to categorize company activities based on the impact they have on the environment. You have regulations that steer investments towards the most sustainable businesses, and so businesses need to publish reports, sustainability reports on their environmental performance. At international level, you have the OECD and the G20, which launched guiding principles to asking states to create legislation in that field. And you have case law of the European Court, and so case law on that stated that inaction was an infringement. So I just wanted to say that legislation is being built up with laws, recommendations, bans as well. The ban on selling thermal engine cars by 2035. And the reason I'm explaining this is because we will address a number of topics in geoengineering, namely, and we need to bear that in mind. This is the context we have to deal with. I was quite optimistic in my remarks, but the truth is, last year there was a sudden decrease in the number of regulations because of the war in Ukraine, and it led to a rise in energy prices. So energy security, geopolitics have an impact on the law. For some, things aren't moving fast enough, given the climate emergency. For others, things are moving fast, given what is at play when it comes to power and security. We will have a debate with different points of view. We will first try to understand the consequences of climate change, and we will ask Damien Huygue to contribute. We will then talk about solar geoengineering. It has a global impact, and to address that topic, we are lucky to have Sofia Kabbej, who specializes in security matters relating to climate change from IRIS. And we also have Aarti Gupta, who specializes in governance at the international level, and she comes from the Netherlands. So we're delighted to have a rather international panel with a variety of point of views. And we also have Director General of International Relations and Strategy of the French Ministry of the Armed Forces, Mr. Guillaume Ollagnier. He will share his expertise on owning the climate security issues. We have a dense, a rich panel. Each speaker will give a short presentation. They will share their points of view, and then we will have a question and answer session. I will let the speakers introduce themselves. And I'll start with you, Mr. Ollagnier. You have the floor. Good afternoon. My name is Guillaume Ollagnier, and so I have to say my title is perhaps misleading. I had a career as a diplomat. I worked on political, military issues, defense issues, and so I'm now Director General of the International Relations and Strategy Department. And I still serve as a diplomat.
Thank you very much. Can you hear me well? Yeah, okay. It's a bit confusing to talk into this mic with this. But I'm Aarti Gupta. I'm a professor of global environmental governance and politics at Wageningen University in the Netherlands. And I'm also one of the co-initiators, and I currently co-lead an academic initiative which is actually calling for an international non-use agreement on solar geoengineering. So I'm also very happy to present that perspective here. Thank you.
Bonjour à tous.
Good afternoon. My name is Sofia Kabbej. I'm a doctor in international relations, and I focus on security and defense, the security and defense dimensions of climate change. And so I will talk about geoengineering, and in my daily work, I try to produce knowledge and help circulate it for policy making. And so I work with the Ministry of the Armed Forces, but also with the Ministry of Europe and Foreign Affairs. Good afternoon. My name is Damien Huygue. I'm a lecturer and researcher at MEAE, Paris. I have a geologist background, and I work on paleoclimatology. And I focus on moments that can be used because they have similarities with what is happening now, climate change. And so trying to understand what might happen in the future. And I will talk about that in a short moment. I'm sure you'll have seen this curve somewhere. Those are IPCC figures. They show the global temperature fluctuations during the industrial period and up until today. What we can see is that temperatures are on the rise, even more so since the second half of the 20th century, and we've reached approximately plus 1.5 degrees Celsius today. And I hope you have understood this is a man-made action. So human activities have generated climate change. That's a given. But based on that, we can try and produce climate models. So two curves have appeared. You have the simulated natural-only activities curve and a simulated human and natural. And what we can see is that we're at approximately 0 degrees with the simulated natural-only curve, and if we include greenhouse gas emissions, then we are close to the rise in temperatures that was measured. It is important because it helps us understand the way climate functions, and we can use models to reflect that, and it helps us when it comes to foresight. Here's another curve based on measurements of global average temperatures up until today, and then based on that, you have a list of scenarios for the future. They are based on geopolitical decisions. Do we continue with the use of oil or not? So the scenario we would want to foster maintains the rise in temperatures below 2 degrees and a return to more reasonable temperature rises. Then you have an intermediate scenario, so +3 to 4 degrees in the centuries to come. Right, I hope you can hear me better. And then we have an oil-only scenario, and in that case, we have an increase +5 degrees by the end of the century, and so +10 degrees within 3 centuries. So this raises a number of issues, a number of questions. Does that matter? What does a +2, +3, +10 degrees increase imply? What are the consequences of all that? One way of addressing this is to take the predictions and compare that with our past. You have the changes in average global temperatures. So we're talking about a million years scale, and so that's since the dinosaurs were wiped out. The temperatures you have here were taken using chemical analyses, and it tells us a lot. First of all, the first thing you can see is, with this time frame, we're talking about cold temperatures. Initially, you did not have ice caps, you didn't have any ice, and so the temperatures were a lot higher, but then they gradually decreased and reached what we have now. But throughout this period, you had hyperthermal events. Small, that is because they only lasted a few 100 million years, but they led to a decrease in temperatures. All those events were related to the changes in the carbon cycle. They were related to the rise or decrease in methane in the atmosphere. So it gives us insights when it comes to measuring climate change. What we need to bear in mind is that all the scenarios we have lined up for the future are scenarios we came across in the past. So for the reasonable scenario, well, a similar climate was the one at the end of Miocene up until the Pliocene period, and 3 million years ago, you had the Pliocene warming, and so we had a plus 2 degrees warming. And so you had plus 450 ppm, that was back then. Now we have 426. And so we can compare the changes. So for the intermediate scenario, we need to go further back in time. We call that period the Oligocene and the beginning of the Miocene. And for a full oil scenario, then we'd have to go even further back. And there are many events similar to what we would face. And so there were no ice caps. I just wanted to highlight one event which occurred 40 million years ago. And there we had a natural CO2 emission event. Volcanoes erupted. So we have this complex graph to the right, but you have the temperature changes on seabeds plus 12 degrees. When we have 2 degrees today, what you have in green, well, those are the high altitude temperatures, 25 degrees during the warming phase. For the tropical temperatures, plus 30. And to the right, you have changes in seasonal changes in temperatures in winter, in the summer. And you have a reconstruction for the Paris area, the Paris basin. What we can observe is that we reach summer temperatures in the sea of 40 degrees Celsius. Another important insight. Well, mostly the summer temperatures are impacted. So you have a system of heavy rains in Paris. So heavy rains in the winter and water scarcity in the summer. And this is important. It helps us understand what a hyperthermal event is. And this climate episode lasted for quite a number of years. So the message I want to convey based on that, when comparing climate change and those events, well, the climate change we face is unique, given its length. The events I referred to last 200,000 years, but we managed to get similar figures within only a few years. And it would be similar to an event like, it helps us better understand the ongoing climate change crisis. We can have information on events beforehand, during, and after a crisis like this one, if we study the past. And another insight is that the climate system on Earth is resilient. Earth has self-regulation properties, and so we could return to levels before we started emitting greenhouse gas. But, as we said, things take time. Thank you very much. Thank you, Damien Huygue. And I'll give the floor to you, Sofia Kabbej. Good afternoon. We've just had a reminder. We've had a reminder today. The context we have today is one of, there are very negative trends when it comes to global warming and CO2 emissions, and there is striking evidence of climate change if you look at ecosystems and even defense mechanisms. And so people start paying attention to technologies, techniques that would help reduce the scale of climate change, or even prevent its effect, and that is geoengineering, modifying the climate, and this is what I would like to delve upon. I would like to clarify two things. First of all, we mustn't mix climate change and weather change. Modifying the weather is, to modify water over a specific time frame. Modifying the climate, on the other hand, aims to modify the climate in the long term at a global scale. And I would like to clarify that second element. When we talk about modification of the climate, we need to make a distinction. You have two categories of techniques. The first one addresses the causes of climate change, the rise in greenhouse gas emissions in our atmosphere. So the goal here is to capture CO2 and store it underground. So that is carbon dioxide removal. That's the first category. Second category, it focuses on a symptom, a consequence, one that was addressed by Damien, that is temperature. There we modify, or there we block a certain level of sun radiations, and that's what we call solar geoengineering, and that is a fundamental element. If we are addressing, and in one case we're addressing the causes, in the other we're addressing the consequences. One consequence, the rise in global temperatures, average global temperatures. And when dealing with CO2 removal, well, we're dealing with a number of techniques that are recognized, but contrary to the modification of sun radiation, and we're still at an early development phase because of the risks and uncertainties. So contrary to that, things are established. Now, I would like to focus on that second category. You have a range of techniques that exist, whitening the sea clouds, or having orbit mirrors, but one that is well funded is the injection of aerosol in the stratosphere. So we're using planes to inject sulfated aerosols to block food radiation using a natural, or mimicking natural analog, volcano eruptions. Those huge eruptions in the past have shown that they reduce global warming. So using the reason that injection technique caught the attention is because the geopolitical context is quite unprecedented and peculiar. This technology raises a number of security issues. Why is that? Well, because injecting stratosphere aerosols will have a global impact, but a differentiated one, with modifications in rainfall, namely. To put things differently, there will be winners and losers at the end of the day. Injecting these aerosols is a technology being developed without any governance framework for research or rollout. And attempts to draft frameworks were met with disagreements, and those jeopardize development or construction in the near future. So that is why I believe it is essential that we address unilateral or multilateral rollout initiatives, and we need to cover the security implications they have. And I'll mention three of them. First one It has to do with potential disagreements between states on the terms of deployment, of rolling out. Do we want to stabilize temperatures, reduce them, to what extent? And of course, as I said it, there are consequences on the regional climate. I said it, there's a differentiated impact. So if there is a unilateral or multilateral rollout, it might lead to disagreement. Some won't have been involved, but will feel the consequences. This would be an infringement of sovereignty, and it could lead to escalation.
Deuxième risque est lié aux conséquences
The second risk has to do with environmental consequences. Consequences that are modelized include the change in the rainfall system, and that risk is because it is impossible to attribute an event, a cyclone, an event, a single event, to attribute it to a technological choice or climate or normal variations in climate. So there's an uncertainty there, and it's very fertile ground for instrumentalization of consequences regarding financial compensation, for instance, or as we saw after natural disasters, foreign interference and manipulation of information. And then the third risk, which is just as important, which is the inclusion of these technologies in power relations, in the race to access technologies, to be able to control the livability of areas on Earth. And this could be another instrument of power, potentially. So it's not just a techno-scientific promise, it is a profoundly political and geopolitical idea.
Merci, Sofia Kabbej. C'est à votre tour.
Thank you. Aarti Gupta, over to you.
Okay. Can I use it like this? Yeah? Okay, can you hear me now? It's all good. And I can, if I stand here, I have a slight challenge. I cannot see my slides anymore without turning. So thank you very much. I'm going to continue talking about this topic of solar geoengineering. And I'm going to pick up where Sofia was explaining that there are many different types of solar geoengineering. And I wanted to link this to the topic of today, which is science diplomacy. So what kind of position should one have in science diplomacy on these very controversial technologies which comprise solar geoengineering? And as I mentioned, I'm also one of those group of academics who's taking a strong position on this topic, actually speaking out publicly about this, not just researching it and publishing articles, but actually taking a position on this. So I wanted to share a bit about that. And as Sofia said, there are different types of solar geoengineering. Most of my remarks are focused on the stratospheric aerosol injection form of solar geoengineering, which is about injecting reflective particles into the stratosphere. And the idea is to reflect some incoming sunlight back out into space and thereby have a cooling effect on the planet, reduce global average temperatures. And just to also specify what this would actually entail, because often it is sometimes suggested that this could be a temporary use of solar geoengineering while we get around to doing what we actually need to do to address climate change. But the word temporary here has a very specific meaning. So essentially, what one would need is hundreds to thousands of specially retrofitted aircraft, which would need to fly 24/7 annually around the globe, around the year, and inject millions of tons of reflective particles annually for decades or centuries. So that is what temporary actually means, that sustained time frame in order to keep global average temperatures down. So with that, Sofia was mentioning natural analogs. So you would actually need something like 1 to 2 Mount Pinatubo explosions per year for decades or centuries. And we can imagine what that would do to complex and nonlinear climate systems. So with that, I wanted to just put this proposition forward that sulfate aerosol injection is a very risky idea for climate policy, for climate diplomacy, and in fact, it should not be pursued. And basically, we can discuss this further during the Q&A and discussion, just to lay out 3 reasons why it should not be pursued. The first is, Sofia also mentioned, winners and losers. Sulfate aerosol injection would have very unequally distributed, regionally unequally distributed impacts on climate and weather patterns. And it would have not just temperature, but also precipitation with consequences for droughts, floods, food systems, etc. And so there would indeed be winners and losers. And that is, of course, that those winners and losers would manifest in a very unequal and structurally, an unequal world that we live in. So we would have to consider who those winners and losers would actually be, to whose benefit would solar geoengineering be deployed. The second reason is that if this technology were to be deployed, it could never be governed globally in a fair, effective, and stable manner over decades, because our global governance institutions are not designed for such planetary scale governance of something which has winners and losers. So the geopolitical risks that Sofia was pointing to would ensure that a planet-altering technology would not be placed under the control of a UN system, for example, where developing countries have a majority. So we'd have to think about whose hand would be on the global thermostat, who would decide when to inject, how much to inject, when to stop, what to do if there are harms, or what sort of liability and compensation, or what even desired temperature to aim for. So that would be a very geopolitically fraught question, and we don't have the global governance architectures to decide that in an inclusive manner in a planetary context. And the third reason would be even researching and talking about solar geoengineering actually poses the very real risk today, let alone the risks that come with the technology. Even researching and talking about it poses the very real risk that we take away the urgency from what we actually know will reduce climate impacts, which is, of course, reducing our emissions and having a just transition away from fossil fuels. And this would be essentially, what solar geoengineering would buy us is not necessarily time, it would buy delay. And we'd have to ask the question, for whom would it buy delay? So with that, I want to just present then these are the many reasons why a large group of academics, and these are a group of academics, natural scientists, social scientists, governance people across the globe, many IPCC lead authors and others, who are now calling since 2022 for an international non-use agreement on solar geoengineering, essentially suggesting to political actors, governments, the United Nations, that this technology should not be developed. And this call has now been signed by more than 600 academics around the globe, and it has been endorsed by more than 2,000 civil society organizations. And what we lay out here as part of what non-use would entail is to suggest that public funding should not go into solar geoengineering research, which leads to technology development. So we also need to be specific about what we mean by research. What we mean here is no public funding for research that leads to technology development, no outdoor experiments, no patents for planet-altering technologies, no deployment, and no support in international institutions. So this is one sketch of a policy proposal that academics have come up with, and it's a suggestion, a proposal to governments in the United Nations and others. And of course, this is a very, very quick sketch of why we have taken this position. We have a number of detailed academic analyses laying out this rationale. So the first one laying out these 3 reasons why there should be, why this is a risky path to pursue, but also looking at how we can learn from other areas of international law. There are other prohibitory regimes in international law which prohibit a whole manner of things. And we have looked into what lessons can be learned to design a prohibitory regime for sulfate aerosol injection or solar geoengineering, also showing that there are many pathways to realizing such a prohibitory regime. It's not that one needs to negotiate a universally applicable treaty, they're very unlikely in today's world, but there are many other ways as well of trying to realize such a prohibitory regime. And we also look at the fact that there are, I'll go through this more quickly, there's more political support growing for a non-use agreement, so it's not just an academic position. African countries in particular have taken a strong position on this. We also have done an analysis of the fact that whatever does exist in international law relating to solar geoengineering is largely prohibitory or restrictive. It is not enabling. And so one can build on that. And we've also done an analysis of why opposition is growing across academia, governments, and civil society, and what are the reasons for that. So with that, I'll just a note about the growing political opposition as well to solar geoengineering in the last 2 years. In particular, just as funding has also racked up from a few private actors. So the funding and support for solar geoengineering is coming from a very small but very powerful group of tech billionaires and others, but the opposition at the same time is growing. And this was the 2025 Conference of Environmental Minister meeting, the 54 African countries taking a position saying that there should be a non-use agreement on solar geoengineering, calling for a UN General Assembly resolution on this. But this is not just African countries, but also some of the most vulnerable to climate change. So of course, we are all very concerned about accelerating climate change, as was pointed out. Some of those most vulnerable saying solar geoengineering is a dangerous distraction, should not be done, Vanuatu, Fiji, and others. So if there's any suggestion that this technology should be developed for the benefit of those who are most vulnerable, we should listen actually to what the most vulnerable are saying about it themselves. And finally, this is my second last slide, the EU has also commissioned, the European Commission asked for a scientific advisory opinion on this controversial issue, which was issued in December 2024 based on an expert review. I was also part of that expert review. And the scientific advisory opinion of the EU suggested, it was very precautionary, it suggested that there should be an EU-wide moratorium on SRM, a moratorium on large-scale outdoor experimentation, and for the EU to support a non-deployment regime internationally. The EU hasn't taken an official position yet, but that was the advice. So finally, in short, to conclude, science diplomacy, I would suggest the need now is to move towards prohibition, because it's much easier to prevent the technology from being developed than to try to prevent its use once it is developed, because once a technology is developed, it will be used. And history teaches us that. So that's just to say solar geoengineering is a dangerous distraction. We don't need it. We know what we need to do to address climate change. That's challenging enough. And in today's world, we talk about the necessarily global solidarity. That seems like, we're living on another planet. But at the same time, that is the essential need of the hour. So thank you very much.
Thank you, Aarti Gupta. Monsieur le directeur Guillaume Ollagnier.
Merci beaucoup.
Thank Thank you. I hope I'm not going to disappoint you, but I appear to be the only one here without a PowerPoint presentation. The title of the round table might have been misleading, but it was a very good title, From Below Ground to Outer Space, Regulations and Climate Challenges. This encompasses the three paths of conflict development. Below ground, the subsoil, the deep.
Donc une forme de logique horizontale. Nous sommes dans une verticalité de la confrontation qui fait que tous les jours, dès maintenant, nous sommes en confrontation, voire potentiellement en guerre, des fonds marins pour la maîtrise des câbles et de la maîtrise des flux de communication jusqu'à l'espace extra-atmosphérique pour all the way to outer space. La captation de flux d'informations en passant par the
capturing of information flows both below the sea and in space. So one of the things we see here in world conflicts, which will probably continue for a while, like global warming with temperatures going up before they drop, this is law and regulation. And what we are seeing is that the whole international legal framework from the 60s to the 90s, sought to organize conflicts, and it is crumbling today. Everything seems to have been wiped from the board since February this year. For the first time since the 1960s, for instance, the nuclear arsenals of the two major powers are no longer limited. It's the first time since the 1960s. I'm referring to the US and Russia. There were agreements and international treaties against chemical weapons and others which are inhuman, and there are more and more countries, first of which is Russia, who are now disregarding this. So there's the weaponization of everything. Today the war is not just a battlefield, anything is a conflict. Grains, rare earths, this was discussed earlier today, artificial intelligence, which was also discussed, algorithms, which are at the heart of things that are immaterial, intangible. These are all sources of conflict, and all this can be weaponized. So to come back to our topic, one of the areas of work of my ministry is to define strategies to avoid future conflicts, see against whom they might be, where and what conditions might be, and this through the lens of our means and needs. So it's an exercise in anticipation. And climate is very complex, but in terms of forecasting, we don't know whether global warming will go up to 8 degrees. What the consequences will be, we don't know exactly, but consequences there will be. So the impact of climate change on future conflicts is a source of concern. In 2016, we set up Climate and Defense and Climate Observatory. Since 2022, we've had a security and climate strategy, and we now have a climate sustainability project as well. So the impacts of climate change on the strategic environment of the country. And this is at a number of levels. The geopolitical level, even though we have as yet to identify a conflict which is due solely to climate change, but the more or less scientific theory is, this was under the former chief of staff, that whatever the geography, whatever geopolitical configurations, the impact of climate change on its human, social and economic and agricultural impact will necessarily bring about tensions and lead to confrontation. For instance, there's the management of hydric stress, water stress. That, for instance, is something which brings about tensions. So for us, it means we need to be better prepared. We need to prepare for more conflicts, which will compound tensions and entail struggles between countries. And there's the impact on the army. Before we, France, are engaged in a conflict due to climate, the simple fact that there is a strong increase, for instance, what we hear is that there are 4 times more natural disasters than there used to be. That in itself has an impact on the role of the armed forces. It's the HADR, Humanitarian Aid Disaster Relief. In France, we all remember the severe storms over the past 2 years in Mayotte, La Réunion, and the Caribbean. And the French army can be called upon for humanitarian support when needed. Partners in humanitarian assistance is a subject, is an area where our partners are asking us increasingly more often to cooperate, especially in the South Pacific, where we have 2 yearly major exercises organized. So even if there is no conflict as such, we may be called upon to help due to the results of climate change. So there's support support with the impact of climate change, but the means aren't always the same. To prepare for tomorrow's war, we'll need more robots, more drones, more aircraft carriers, twice the size of today's aircraft carriers. But if you're talking about climate disasters, it is of no interest. So we need to look at the means and capacities. And the third impact is that we need to prepare for a military intervention in real conflicts, which are different from what we're used to, sometimes when temperatures are much higher or much lower than we're used to, according to where we would be called upon to intervene. You have to protect the troops against extreme temperatures, so you need transport vehicles which are adapted to this, and there have to be combat helicopters which can intervene even when temperatures are high, extremely high, and you also have to be able to go to cold regions. Recently, we've all been looking at Greenland, and it means that you need the necessary equipment, and batteries in particular, which can stand very cold temperatures. So that all has an impact on how the specificities and technical standards of our equipments, these all need to be revisited because we might be needed in places where the temperatures are extreme. So that is very important for the ministry and has been for several years now. As to geoengineering, following upon the earlier presentation, that is another source of concern for us. Climate is something that we will have to face, and there will necessarily be an impact on the number of conflicts and the risk that France needs to intervene. The materials, the equipments will be needed, and how often we will be called upon to give humanitarian assistance to the populations. As I said earlier, what we see is that there is no area today which isn't weaponized. Anything is made use of in the competition between states. This is true in open conflict, but it is also true for the competition before a conflict is started. If you look at the US and China, everything is being done to try and hamper the other's ability to become or remain the #1 world power. Everything, rare metals, rare earths, or anything goes to limit the access to these materials. So climate change could sooner or later be used, weaponized in order to weigh on the strategic advantage of one side, or to change conditions of economic development of the enemy, the adversary. So this is something that we are monitoring closely at the observatory. We are following all international discussions on the subject, and as I said, everything is being weaponized today, and if the technology were to become mature, you can't exclude that it might be weaponized in its turn. And these technologies are being increasingly produced by private companies, and they have the financial clout to move ahead here, and their role in future conflicts is also becoming more and more likely. And what you see is increasing offensive attitudes of some states, but they all hide behind plausible deniability. And that is the sort of action which could also be included and could be a problem for a country suffering from climate change brought about by some other party, and with a private group being responsible. So you're looking at the competition between states, the risk of it being very difficult to pinpoint who is the source of the problem. So to conclude, it's a topic which is both new and old. In 1886 or 1889, Jules Verne wrote a novel, Sans dessus dessous. It's not very well known, and the relationship between climate change and the military-industrial complex is described in this book. There's a club of artillerymen and an artillery company in Baltimore which has a full order book and decides to develop a super cannon which will be hidden somewhere in the world and will, by one shot only, change the axis of the world, making it perpendicular to the sun, which of course would have an impact on climate. And when you look at more recent history, that is last January, it would be a way, for instance, to allow agriculture in Greenland. So there'd be a sort of a Greenland spring, which could then be made use of by American farmers. So climate change, in order to lay hands on resources, is not something entirely new. So once a call again, Jules Verne and his foresight are of interest here.
Merci à toutes et tous pour l'exposé.
Thank you. Thank you all for your presentations. Now we have a Q&A session. So let me start off with a question to you, Sofia Kabbej. What I gather from your presentation and that by Guillaume Ollagnier is that private operators in geoengineering are emerging through fundraising. There are legal loopholes. Is some kind of international regulation emerging or national regulation emerging in some countries, or is there a legal vacuum? Yes, that is a fundamental issue. For a long time, this was funded by public money, a lot of philanthropic money in the United States. And I would like to say here that the US have a dominant position in research, but also advocacy and funding research outside of its own territory. So that's a dominant position, which means that they are pushing out other actors. It also they also control the narrative, as it were. So there are issues of representation. So I'm talking about the US because that is where you have the highest concentration of funding. As I said, public money, philanthropic money. And since 2023, there's a new phenomenon, private players that are raising funds, but that also have their own private money. So people like you and me fund these private initiatives, and the amounts easily exceed public money. So just to give you a salient example, 2025, the AREA agency, UK Innovation Funding, gave out its largest grant, £52 million, 12 projects, the highest grant ever. And the startup that raised the most money, Startup Solution, Israeli-US venture, $75 million for one project. That's their capacity. And the project, as we said, aims at selling the product to a government as yet unnamed. So is there regulation? No. Are there limits, restrictions? No. But this is interesting. On a national scale, and particularly the U.S., against the backdrop of conspiracy theories that I could tell you more about, we see some restrictions emerging in some states that believe in chemtrails, the trails left by aircraft, the aim being to exert mind control and control births, and they confuse climate change with chemtrails. And you have conspiracy theorists that have stopped all funding for science on the basis of these conspiracy theories. So there's not a legal restriction, but that is what is restraining these initiatives. And so there are initiatives that are privately funded. We don't really know anything about the project except the promised profitability, and everything is in a dark box. Everything's very, very opaque. So there's a legal vacuum, but there is no transparency on the impacts of these activities, so this might have legal impacts as well. And then there's the issue of liability. It's impossible to determine what the causes might be, consequences might be, should there be something that looks like a weather change, but that might actually be the result of the use of one of these climate changing technologies. So how do you ascribe responsibility, liability, for example, to states? And I think that really undermines the rule of law from a regulatory standpoint. That's how you would see things. So, Aarti Gupta, I have a question for you. Are there legal means to limit the deployment of geoengineering? For example, measures to be taken against businesses that want to deploy some of these technologies? Can states ask for a moratorium, for example? Have you looked into these possibilities?
Well, yeah, thank you very much for that question. I think there isn't exactly a legal vacuum on governing these technologies. So at the international level, we do have the Convention on Biological Diversity, the CBD, which has taken a position on solar geoengineering, other forms of what they call climate engineering, and there's a de facto moratorium on any kind of research which might have adverse impacts on biodiversity. And if solar geoengineering or SAI were to be deployed, it would contravene existing international obligations of the Montreal Protocol on ozone depletion and other international treaties. So it is not that there's an absolute legal vacuum. There are existing international obligations on things on addressing climate change, also ozone depletion, but also human rights obligations and other things which would have to be taken into account if one were to govern solar geoengineering and regulate it. But also in terms of private actors, and what if private actors cannot operate in a complete vacuum, of course. So if they're going to do outdoor experimentation of some scale, that would have to come under some sort of national oversight. They might have to ask for permission. Now, this is a very nebulous space. And so what we did have, actually, we had one example of before Stardust Solutions, which is this, what Sofia was referring to, a recent development. It's an Israeli-US startup which has raised $72 million, and it is trying to develop this technology. But before that, we had a private initiative called Make Sunsets. It was a startup based in California, and it was two entrepreneurs who wanted to sell cooling credits. So it is nowhere near the scale of Stardust Solutions, but it tried to do some outdoor experiments by releasing balloons into what they said would reach the stratosphere. And this activity, they first tried to do over the territory of Mexico. So they, instead of doing it in California, they drove down to Mexico and they tried this out. And the Mexican government did not appreciate this. And so after this activity, actually Mexico was the first country in 2023 to ban any outdoor experimentation. So private activities can have these direct consequences of regulation. So Mexico is a clear example of banning outdoor experimentation. And I think, I mean, the question remains how activities like Stardust, which claims it has just put out some guidelines on its activity just 2 days ago on its website. It says that it will only proceed with clear government oversight and permissions, etc.
Peut-être juste un point sur la gouvernance, en fait, Aarti le mentionnait.
So on governance, just to add to what Aarti said, so we have the CBD indeed. However, the United States are not signatories, and they are leading in this area, and they wouldn't have to abide by that law. There's also the Anode Convention that bans the modification of climate for military means. So the scenario in which these technologies could be used for hostile ends or for military ends is banned under the convention. But the convention is not signed by many states, including France and Israel. So there are areas that are not covered by these conventions. There's also the notion of intentionality. You have to be able to prove the intention to use technologies for hostile aims. And they might just deny, no, I just wanted to see the effect over my territory. I did not intend to create a negative effect over your territory. So there are legal provisions, but they would only apply partially, and there are gaps, and that's an issue with these global reaching technologies. Yes, and indeed we do see that international law is being weakened. There's also competition between domestic laws. Some may allow experimentation, while others do not, adding a further layer of complexity. Damien, I have a question. You said, I believe, that the singularity of the climate change we're experiencing is the speed at which it is changing, at the speed of a meteorite, I think you said something like that. Do you get the feeling that this is a message that is being heard by public authorities? And does the scientific community have a role to play in explaining the situation to policymakers, to the public at large? There are a number of climate litigations. Climate litigations are developing. Climate cases are being brought to the courts. And do you think that scientists should be brought in to testify or provide an expert testimony, for example? Thank you very much. Now, to answer the second part of the question, yes, indeed. Scientists have knowledge. Their knowledge should remain factual, and those facts should be the basis for decisions, including court rulings. To answer the first part of your question, scientists, their role is to communicate, to talk with policymakers, and that is the role, for example, of the IPCC. But indeed, it's important to speak to a broader base, to have a broader impact. There are difficulties to that. In France, for example, researchers have freedom of speech, but that's not the case in many countries. There are some countries where scientists, or at least the place they're given, is receding because decision makers don't want them to speak up, and so that's a big difficulty, that's a barrier. Guillaume Ollagnier, you talked about weaponization, that everything is and can be weaponized, and that is specific to our times. How is this a special geopolitical era? We have conflicts. What is the linkage with the climate environmental transition? Are these geopolitical events slowing down the European Union's environmental transition and the environmental transition of the rest of the world in pursuing the Paris summit's objectives? Well, I'm not sure I can answer all of your question. We can look at two conflicts, the Ukraine and Iran. Both conflicts have shown how, within the context of conventional conflicts, everything and anything can feed the conflict. Even before open war begins, before Russia's aggression on Ukraine, we saw that Russia bombed or threatened to bomb some civilian infrastructures, ports, and so on, to hamper Ukraine's wheat export capabilities, and the rest of mostly Europe and the southern part of the Mediterranean thought they weren't going to, thought that their food industries would collapse. Remember that at the time many initiatives were taken to restore freedom of movement in the Black Sea. And therefore, we had to support Ukraine, But the danger was destabilization in many countries with tens of millions of people, for example, in Egypt, being threatened with famine practically. And for the conflict at present, everybody will remember the closure of the Strait of Hormuz, although that was not the object of the war, but it is a consequence of war. Iran has been given an additional means of pressure with the closure of Hormuz at will. And that really has posed an economic problem for Gulf countries. We've seen that this is being like a sword, like a knife to the throat of European countries. I mean, half of French people wouldn't be able to locate the Strait of Hormuz on a map, or were not able to before, and now that's all everyone is talking about. So before the military conflict and during the conflict, everything and anything can be weaponized and is, because this fuels the confrontation and antagonizes sides. Thank you. We now have questions from the audience.
Alors, ce serait une question pour commencer
A question starting, a question for Damien Huygue. As was said, the present climate change at present is unprecedented. There are scenarios studying paleoclimatology. Can they be applied to the present crisis? And if so, how? Thank you for that interesting question. As I tried to explain during my presentation, all past episodes of climate change can be considered as best as partial analogues of our present climate change period. Continents have shifted, so the situation is different. And indeed, the phenomenon is, the pace of the phenomenon is much quicker than in the past. So that will obviously have a big impact on, for example, the evolution of the biosphere. Living species will respond to the climate event depending on its pace. But there are other things that can be transposed or replicated. For example, when the climate gets warmer, how will rivers be affected? Will the flow of rivers be directly affected by the increase in temperatures? We can use data from the past. So there was an event 40 million years ago, and we have rivers in the Pyrenees Mountains that saw their flow increase three times, and so we can expect that, and so we can relate that to the big river overflows and floods that we've experienced in those regions in the past 2 or 3 years. So we can take the experience of the past and it's directly applicable to today. The same goes for seabeds, intensity of erosion, sedimentation patterns, impact on living species that produce calcium, such as corals. All that is impacted by climate change. A question for Aarti Gupta. Banning research at a time when science is being pointed at as something risky, should research not be authorized, but be subjected to some kind of ethical supervision?
Yeah, thank you for that question. Of course, it is a sort of $64 million question, and it's especially for a group of scientists and academics to say that there's something that maybe it's better off we don't know more about. It's a very difficult position to take. So these 600 scientists, I mean, we're all academics because we believe in the power of knowledge generation and research, etc. But I think there are things where society decides that maybe we could develop the technical knowledge and the know-how. Humans are endlessly ingenious. And so, for example, human cloning, we could develop the technical capabilities and the scientific knowledge to be able to clone humans, but societies have decided that maybe that's not a path we want to go down. That's not an area where we want to develop that technological capability or the scientific knowledge associated with that technological capability. So I think that it's a challenging question. Of course, there's also a lot of, there's a nuance in what one means by research. So this is not to suggest that there should be no modeling, no climate modeling, not global social science research, or all kinds of what actually constitutes research and what is it that should be restricted. What we are saying in the non-use initiative is outdoor experimentation, for example, which has the explicit objective of developing the technology. So it's not about exploring aerosol interactions with clouds or in the stratosphere, etc., that kind of fundamental research, which might be very closely related to basic climate research. It's more about what are the mechanisms by which one could get certain reflective particles into the stratosphere. So the mechanisms of intervention or the kinds of particles that could be used, this kind of outdoor experimentation can lead to technology development. And our position there is that that's a risky path to go down. So because once a technology is developed, then the scientists who develop it will not be the ones who decide should it be used. So every scientist researching SRM today will stand up and the first slide in every presentation will be, this is not a substitute for ambitious mitigation first, emission reduction first, but that scientist is not responsible to ensure that mitigation will remain first. So they can declare it, but they are not the ones who are going to ensure that that will happen. So how will this technology be used if it's developed to whose benefit? I think these are political questions, and there's a moral responsibility, I think, on scientists to think about how their knowledge gets used in the world and in a highly unequal world, and whether they are willing to accept that moral responsibility.
Sofia Kabbej, est-ce que tous les scientifiques ont une
question for
position
Sofia
unanime
Kabbej.
sur cette question?
All scientists aligned
Non, vraiment
on
pas. En fait, c'est ça tout l'enjeu. Et ce qui est très intéressant,
No,
c'est que
they're
c'est
not.
vraiment
That
un champ de
makes
recherche qui est
things
extrêmement
difficult or
polarisé,
challenging. There's
avec
a lot
d'un
of
côté du
polarization
spectre, on
in
peut
this area of
retrouver la
research. You
position
have the
qui est
whole
défendue,
spectrum
par Aarti, et de l'autre côté
from the
du spectre,
position
vous
defended
avez,
by Aarti,
tout
right
un
over to the
groupement
other end of the
scientifique,
spectrum, a group of scientists mostly in the Northern Hemisphere, mostly English-speaking countries, who promote the risk narrative. Risk associated with the increasing global temperatures are perhaps so huge that they mean that there's a moral imperative to finding solutions that are perhaps just as risky. So it's not a risk-benefit ratio, it's a risk-risk ratio. They say it's our duty as scientists to find solutions, and the more we know, the more we'll be able to decide if we use or not the technology. I agree with Aarti when with what she said. The scientific ecosystem, when the scientific ecosystem is mostly made up by modelers, that's a specific set of scientists, and in that community, it's very difficult to think in any other way than they've been trained to do so. For example, all of the assumptions that underlie the consequences of the particles sent out in the atmosphere, it presupposes that there's an agreement to go that far. Let's do it first, then we'll think about how we deal with the consequences, whereas we should start with the second part first. And I think there's also a rift between Francophone and Anglophone research communities in France. Yes, we do set limits. Some research is seen as illegitimate, whereas in English-speaking countries, there's a large community amongst the scientific community that is pro-research, pro-experimentation, very hands-on. The narrative is models don't give us good results. We need real-scale experimentation to gather real data. In 2026, we will see these first experimentations with, for example, with Stardust Solutions and other projects funded by the British agency. And so we're really at a pivotal moment in terms of in the development of technology.
One small point there about the scope of what would research outdoor experimentation actually tell us. So if we were to accept the argument that there are uncertainties, let's try to reduce those uncertainties. This sounds very, very logical and reasonable. But of course, we have to ask ourselves whether even large-scale outdoor experimentation, let alone small-scale outdoor experiments, will actually tell us what we really want to know, which is that question, will the risks outweigh the benefits of doing solar geoengineering? And we cannot know that at the planetary scale. The only way to know about planetary scale impacts is to do planetary scale experimentation. And that is the same as deployment. Short of planetary scale experimentation for a sustained period of time, we simply don't know what the climatic effects will be and how they'll be regionally distributed. And so that is then the question, you know, what will anything short of that actually tell us? Meanwhile, there are all the other risks of having a position which says, let's do the research. And that is that as long as something is happening, we're putting scarce resources into something that may be actually very dangerous. So climate finance is scarce enough. Should we be putting our public resources into this? I mean, I could say much more, but I won't.
Juste pour ajouter une petite anecdote.
Yes, I wanted to add a story, an anecdote. So this isn't really an experiment, but something that happened about 200 years ago. A natural impact from the discharge of particles into the atmosphere after a volcano eruption. 1789, the French Revolution. 6 years before, two things happened. The École des Mines was founded here, but there was also a volcano eruption in Iceland, 1783, that lasted close to a year. For a number of historians, and Guillaume recalled this a while ago, no climate event alone led to a conflict or a war. However, when there are climate disruptions, if there is already a favorable ground, for example, political tension, if you add a climate event, this can tip the scales. And that is a theory. The 1783 Iceland volcanic eruption damaged crops for the next 3 years in all of Western Europe. Sulfur odors were reported through to southern Italy for those next 3 years. And this led to protests, and slowly this built up, and the theory is that this may have tipped the scales in favor of the French Revolution, with sending people to the streets. In the streets. And so, yes, things can have uncontrollable consequences down the road. Thank you very much for that additional information. Another question now for Guillaume Ollagnier. Hasn't the war in Ukraine already reached a climate dimension? Of course, we know there are other issues, i.e. the decision to invade the country was perhaps due to climate warming being taken into consideration. Right, well, I'm not sure I understand the question, but what is sure is that the conflict, yes, indeed, is closely related to the weather. And when winter arrives, this truly modifies the conflict every year. Russians target energy production facilities in order to impact morale amongst troops and civilians, especially this year because the winter was especially harsh, -25, no means for people to turn on the heat, etc. Towards the end of the winter, operations stall because as ground thaws, it becomes too muddy to do anything. And then when summer comes around, fighting resumes. So the weather and the temperature indeed has tactical implications on the ground. So was the conflict triggered because people had already discounted or factored in climate warming? I'm not sure I'm able to answer that. The determinants, as Vladimir Putin says, or the profound roots of the conflict are manifestly different, but I may be wrong. Microphone does not seem to be working. Right, we have reached the end of this roundtable. We've been debating for an hour and a half. This has been very interesting. Thanks to everyone for their contribution, including the audience for their questions. Thank you.